Do you want to learn how to find prime numbers in Java? Whether it's all primes between 1 and 100, 1 into any number you choose, or even the first n prime numbers, this video is for you. By the end of this tutorial, you'll know how to write a complete Java program from scratch, understand the logic behind prime number detection, and be ready to apply it in your coding projects or interviews. Section 1. What is a prime number? Before we dive into code, let's define what a prime number is. A prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. In other words, it's only divisible by 1 and itself. For example, 2, 3, 5, 7, 11, 13 are all prime numbers. Numbers like 4, 6, 8, 9 are not prime because they have additional divisors. Keep that in mind, it's the foundation for the program we're about to write. Section 2, First program, primes between 1 and 100. Let's start simple. We'll write a program to find all prime numbers between 1 and 100. Step 1, we need a place to store the primes we find. For that, we can use a list of integers. List integer prime numbers equals new array, list. Next, we'll loop through numbers 2 to 100 using a for loop. 4, int number to check equals 2, number to check less than equals 100, number to check plus plus, / check if prime. We start at 2 because 0 and 1 are not prime numbers. Section 3, how to check if a number is prime. To determine if a number is prime, we check if it's divisible by any number from 2 up to half of that number. Why only up to half? Because no number greater than half of a given number can divide it evenly, except the number itself. Inside our loop, we'll use a nested for loop. 4, int factor equals 2, factor less than equals number to check, 2, factor plus plus, if, number to check percent factor equals 0, is prime equals false, break. Here, percent is the modulo operator, which gives the remainder after division. If number to check percent factor equals 0, it means the number divides evenly, so it's not prime. We use a boolean as prime variable, initialize to true, and set it to false if we find a divisor. The break statement exits the inner loop early because we already know the number isn't prime. After the loop, if is prime is still true, we add the number to our list. If is prime numbers add number, 2, check. Section 4, printing the primes. Once the loop completes, we simply print all primes found. System.out.println prime numbers from 1 to 100 are 4, int number, prime numbers. System.out.println number. Running this program gives us all primes from 2 to 97, exactly as expected. Section 5, expanding to user input. Next, let's make the program flexible so we can find primes up to any number n. We'll use the scanner class to get input from the user. Scanner equals new scanner system.in, system.out.println please input the limit, int limit equals scanner.nextInt, then, replace the hard-coded 100 in our for loop with limit. Now the program prints primes from 1 up to whatever number the user chooses. Section 6, finding the first n prime numbers. What if we want the first n prime numbers, regardless of how large they are? For this, we use a while loop instead of a for loop, since we don't know how high we'll have to check. We initialize. Int number to check equals 2, int count equals 0. Inside the loop, we check if the number is prime as before. Each time we find a prime, we increment count. Once count equals the number of primes we want, we use break to exit the loop. This method allows us to generate the first n prime numbers efficiently. Section 7, performance tip. A quick tip, for very large n, checking every number up to half of the number can be slow. You can improve performance by checking factors only up to the square root of the number. This reduces unnecessary checks and makes the program faster. Also, printing primes as they are found, instead of storing them in a list, helps when generating very large lists, so you can see results in real time. And that's it. We've learned how to find all primes between 1 and 100. Find all primes between 1 and n, user input. Generate the first n prime numbers. We explored loops, nested loops, conditional checks, and modular arithmetic, all of which are essential Java concepts. If you found this video helpful, give it a thumbs up and subscribe, it really helps the channel grow and reach more learners. Keep practicing, experiment with larger numbers, and in the next video, we'll explore an optimized algorithm to find prime numbers even faster. Thanks for watching, and I'll see you in the next tutorial.